Okay. So before we figure out the change of, oh, Aliza has also just joined in, connecting here. Cool. Okay. So before we talk about what is the effect of change of pressure, tell me, what do you guys understand about pressure? What does it mean, or how do you feel it? Like, what do you know about pressure, Abhita? Anyone? Like, whatever.
Can you repeat the question?
What is pressure? What do you understand by pressure?
And pressure is a force exerted on an object.
Okay. So pressure and force एक ही है क्या? Like, are they interchangeable?
Different.
How are they different?
Pressure is a force applied on a certain area.
Okay. Force apply matlab,
But
yeah.
technically, force is also applied only on a particular area, right?
Particular area. So what is the difference between force and pressure? Why do we have a separate thing called pressure? Okay, so the difference, like what exactly pressure is, you guys have come close, Jaydeep. It is a force, but so pressure is equal to, so it's basically the force applied per unit area. Okay, so force can be applied, right? Like if I'm applying force with a finger, itna sa rahega. If I'm applying the force with my whole hand, it's like it's going to cover this whole thing. So that is force, like by how much I'm pushing, like that's the force applied. That you guys understand pretty well. But when it comes to pressure, what is the force applied per unit area? So if I'm doing this, for each centimeter square or one tiny unit of area mein, kitna force is applied? As opposed to if I'm doing this, tiny 1 centimeter square pe kitna force is applied? Yeah, so that is the difference between pressure and force. Force is like the overall thing, but if I'm comparing just one tiny bit of area, what is the difference between if I'm pushing it this way versus if I'm pushing it this way? Okay, so it is the force applied per unit area. So ye pehle bhi you must have come across, no? Like when you're walking on snow or sand, why can't you walk in high heels when you're walking on sand?
Because I think it would go through
Ma'am, because the pressure exerted is.
the pressure will go like make it go through the sand
Correct.
instead of like just staying on top of it.
Yes. So if I have a high heel stilettos, it's only this much that's, and thoda sa like on top, that's going to be pressing on sand. As opposed to a normal flat shoe, ye pura area is going to be on sand. Okay, this does not look like a shoe, but imagine it's like a slipper ka shape. Okay, so this whole, the same force of your body weight is spread out over this whole area versus being spread out in this tiny area. So in which case will pressure be greater? Like what do you think will be the pressure between, if you compare both these scenarios?
I mean,
On
the
the smaller area.
Yeah, Jaydeep, first you were saying?
pressure exerted would be much more than the slipper or the shoe in height.
Huh. And Aliza, what were you saying?
It's on the smaller area.
Same thing, yeah. Smaller area, so area kam hua, so when you divide it, this overall fraction will be greater. The pressure will be more in this case, which is why more pressure you start sinking in the sand compared to using a broad thing. So that's the difference between force and pressure. Both of them are like, okay, ek hi action hai, but force is like the overall thing. Pressure is per unit area kitna hai. Okay, so that's pressure. Now coming to solid, liquid, gas. Let's look. Let me take a liquid. Okay, liquid hai. So particles are close to each other, but they can flow around each other. I took liquid because it's in the middle. So is taraf ja sakta hai, us taraf ja sakta hai. That's why. Now, if I exert pressure on liquid, like if I'm increasing the pressure, increasing pressure matlab I am pressing down on it. So liquid pe pressure zyada hoga, like force is exerted on the liquid. So what do you think will happen to all these particles?
They will get compressed together.
They will get compressed, absolutely. So uska consequence kya hoga if they are like compressed and compressed and compressed?
The liquid will turn into solid.
Correct. Yeah, so you're pushing them close together. So intermolecular forces, like the intermolecular spaces are decreasing. So agar liquid hai, to that is going to turn into a solid.
But I thought liquid could not be compressed.
Liquid cannot be compressed, but if you're applying so much force, so basically if you're increasing the pressure on a liquid, if you're making it like it cannot be compressed easily. If you're increasing the pressure so much, it's going to turn into a solid. You need to spend a lot of energy on it in order to increase the pressure on it. But yeah. Iska flip side, okay, instead of increasing pressure on it, if I take the same liquid, let's say there's a movable thing, and I am decreasing the pressure on it. Pressure decreases matlab I'm pulling this upward. I'm creating so much space that इसके ऊपर ज़्यादा pressure नहीं है. There's a lot of like free space over it. So then what do you think will happen?
I didn't get it.
Hmm?
I didn't get it.
So if I have a liquid and if I'm decreasing the pressure, so there's nothing pressing down on it. In fact, I'm doing the opposite of it, I'm decreasing the pressure on it.
Mm-hmm.
So what will happen to this liquid? What will happen to these particles?
Nothing will happen.
No. So this is turning into this sort of a situation. So there's like a lot more space, vacuum create hua. So these molecules have like a lot more space to move around and slowly they're going to escape out. So a decrease in pressure turns a liquid into a gas. Like let me just pull up that simulation. Thoda visual se you'll be able to get it better. States of matter. Actually, like once we're done with the class, let me know. I'll share these links with you guys. You can like play around with it. Okay. All right. Let's take water and I'm gonna increase the temperature. Okay. Abhi liquid hai na? Do you guys need a refresher? Okay. 310 Kelvin matlab what is the temperature Celsius mein?
Just put it in degrees Celsius. No?
Yeah, that's what I asked. Like Celsius may what?
No, can you change the Kelvin into Celsius?
How do you change Kelvin into Celsius?
I don't remember.
273.
It's room temperature, 310 Kelvin.
You don't remember means last class में किए थे ना? Like check your notes. Do it. अभी calculate करके send it on chat. What would be the temperature Celsius में? Roshmit sent. Oh, good. Quick calculation that was. Jaya, okay, proper accurately. Neve. Okay, close enough. You just need to be careful with your addition, subtraction. Silly mistakes. Not karna. Jaideep got it. Good.
Is it 38?
Check the calculation. Pretty close, but yeah, around that range. Check.
No, sorry, 36.
36 point. Won't be exact. though.
Yeah, 36 point something.
Yeah, there you go. Here. So, to convert Kelvin into Celsius, you subtract 273 from it. So Celsius find out करने के लिए it's 310 minus 273. You want it to be accurate, 273.15. Okay. So अभी room temperature है. So I've chosen water. So it's in liquid state. Now, if I increase the temperature, let me. Okay, around 310 Kelvin. Now, when I decrease the pressure on it, I'm not able to control pressure. Let's do this. Okay, I'll do one thing. So increase temperature. Okay, so now I've turned it into steam. So this is all in like gas phase. When I increase the pressure on it, while trying to keep the temperature same, the issue with this is changing the things only according to the thing.
It's what exploded or will push the top blade off? Oxygen at room temperature, let's see. Yeah, so I'm not able to control both of them independently. It's only going along this line. I need to keep the temperature constant in order to get this done. So, okay. Let's do it again. Get a better thing. Okay, the point is, so we have solid, liquid, gas. When I want to convert solid to liquid, either I can Evaporate it or vaporize it.
Hmm?
It does this, right?
What's that?
The triangle, right?
No, now I'm just looking at conversion. Okay, so when I want to convert solid to liquid, either I can increase the temperature. Similarly, even to convert liquid to gas,
you can increase the temperature. But what if you don't have, what if you cannot change the temperature? What if you want to keep the temperature constant, but you want it in a different phase, like whether to do experiment or chemical reaction, whatever it may be. Like for example, if you wanted to get like liquid nitrogen, so that's used in cooking, it's used in a lot of, like even liquid oxygen, liquefying oxygen. So if we were to do it only using temperature to like decrease the temperature to convert from gas to liquid, it's going to take a lot of energy. Increasing the temperature is easy. You just start a fire and you can increase the temperature. But decreasing the temperature, that's what, like you have whole refrigerator for that, right? Usko temperature decrease karne ke liye. And that takes a lot of electricity. And that's just to decrease it to like 0 degrees Celsius, -4 degrees Celsius, -15 degrees Celsius. But if you want to convert a gas like oxygen or nitrogen into liquid state, your regular freezer also will not work with it. So along with decreasing the temperature, another way you can do this conversion is by increasing the pressure. Okay, so one is temperature. Say you can change solid liquid gas. You
I
can
didn't get it. So by like increasing the temperature, solid can become liquid and liquid can become gas. And by reducing the temperature, gas can become liquid and liquid can become solid.
yes. So temperature is one thing you can change in order to convert from solid liquid gas to the other state.
So like ice becomes liquid, water becomes gas. Decrease the temperature, gas becomes liquid freezes to become ice.
Absolutely, exactly. So that is with respect to temperature. So another thing you can use in order to do the same conversion is by manipulating the pressure. Okay, so solid se liquid karne ke liye and liquid to gas, if you want to increase the space between particles of matter,
We'll have to decrease the intermolecular forces.
correct. And
So what does that break the space between the molecule, like extra pressure on ice? Does it break the ice into liquid,
yes,
or
okay.
break it into smaller pieces which later on become liquid? That it basically relates to temperature.
Yeah, break matlab it basically increases the space between the individual particles, and how they are packed basically is whether something is solid, liquid, gas, right? So increasing or decreasing the pressure manipulates this particular space between the particles. So that's what we're doing by manipulating the pressure. Okay, so how do I get this intuitively for you guys? Do you know how vacuum is created? What is vacuum?
Yeah, vacuum is when there is something at zero pressure, zero oxygen, like literally almost nothing, and it is surrounded by like lack of air, like space. Like space is a vacuum. You can create that also, like using a vacuum seal bag and a vacuum creator, something like that, right?
Correct. So vacuum is basically absence of everything. And when I say everything, like it's literally absence of everything.
Literally everything except for the object in it.
No, not even oxygen. Agar oxygen hai,
No,
to
no, not oxygen, object. Like if you put an ice, you can vacuum seal the ice, but the ice will still be in it.
vacuum sealing is different. So vacuum is basically absence of everything. Like if I take an empty box, if I take it here on earth, usme fir bhi there'll be some amount of air in it, right? Like whatever is the volume of the box. Now, if I suck out all the air, if I take out all the air like nitrogen, oxygen, carbon dioxide to the air, so literal absence of everything is vacuum. Okay, so now what you're saying, so if I take an ice block, agar iska vacuum seal kar rahi hu, like if it is vacuum sealed ice, it means that there is nothing except ice, like there is no space, everything else is sucked out. Now, without adding everything, like without adding any extra matter, if I create space over it, ice है मेरे पास. Initially, it was vacuum sealed, and without adding any air or anything at all, if I increase this thing, so what I'm essentially doing is I'm decreasing the pressure on it because there's nothing else pressing on this ice. Don't note down anything right now, Prashmit, Aliza. Yeah. So when there is less amount of things pressing on this ice, I am I'm decreasing the pressure on it. Does that make sense? Like, are you able to connect it somehow? Getting it?
No.
So pressure is basically something pressing on it. So if I put a block of ice in an empty box, इस पे कोई pressure difference नहीं है because there's still air all around, which is basically pressing on it from all the directions. Air molecules here, that's going to apply pressure on the sides.
Okay.
So when I'm decreasing pressure on it, I have to reduce the quantity of air that's like pressing on this ice.
In the bag.
Yes, in the box.
So does that mean you have to vacuum the bag?
So that,
not in the literal sense, but
yeah. So I have to suck out some of the air. So best way to do it is I basically vacuum sealed the ice so that there's nothing else apart from ice. And then us vacuum seal ke baad, like I'm basically increasing the space in that bag without adding any air or anything. So this, all of this is basically empty space. This is basically vacuum. Yeah, Sahil, what's up?
does, like for example, if you vacuum seal something that can melt, like ice,
Yes,
so then does it melt?
it melts. That's what
Even
I'm
if you have vacuum sealed it.
If I'm vacuum sealing it, it won't melt. Nothing will happen because I haven't changed anything. But vacuum sealed ice may, if I reduce the pressure on it, like if I start, so think of what is happening here at a molecular level, right? So these are the ice particles. They're all like rigidly arranged against each other.
Yeah.
Now it holds a space, like if ice is basically in real life, around it there's air all around, so air molecules,
Yeah, a little bit of chilled air.
yeah, whatever molecules, oxygen molecules, nitrogen molecules, all of that's gonna
CO2.
each other. CO2, absolutely, anything that's present in air. So air exerts pressure over it, so that's what atmospheric pressure is, right? Like the pressure that air exerts over you, that's what you feel as wind and breeze and all that.
Then
So
what about dry ice?
dry ice is solid carbon dioxide. That's a completely different.
No, like when you put it out, like I don't know what to say, like when you pour water on dry ice, how it steams, and even if you keep it normally, smoke comes out.
Yeah, that's because of the temperature difference.
Yeah, but
Dry
if
ice,
you vacuum seal it, won't the gas still come and then just like have air? Then won't it become unvacuum sealed? I don't know the word is.
if you vacuum seal it and take it out from there, yes, there is pressure difference, there is temperature difference, so that is going to turn into
Water?
gaseous CO2. That's why you have all that smoke coming out of it, no?
Yeah, so then that means the bag still has air in it. So it isn't vacuum sealed, right? Because the air is coming out of the ice and into the bag. So the bag doesn't become vacuum sealed, right?
Then it's not vacuum sealed.
Because it sucks, yeah. So even if you vacuum seal it off first, but then the gas comes out, then it becomes unvacuum sealed.
It's the other way around, Sahil. If it is sealed, it means that nothing can go in, nothing can go out. If you're opening it, you're not sealing it anymore, which is why you have the gas coming out of it. Okay. But yeah, the situation you're describing is not perfect. Like it's not something we can talk about because वहाँ पे temperature difference भी हो रहा है, pressure difference भी हो रहा है, बहुत कुछ हो रहा है. So coming back to what we're discussing now, ice in like normal condition, the water molecules are packed tightly over here, and इस पे atmospheric pressure लग रहा है. So let's take the same ice and keep it in vacuum. So let's say this is the vacuum chamber. And if we keep this ice here, so यहाँ पे 1 atmosphere pressure लग रहा है ice पे, but because this is a vacuum chamber, because इसके अंदर कोई air नहीं है, there is nothing inside it, this is at 0 atmospheres. Okay, there is no pressure at all. So the natural tendency when you do this, so one thing you need to know about any sort of matter is gas, molecules, particles, whatever it may be, they always move from a high pressure area to a low pressure area. So gas molecules always want to move to low pressure area. Okay, so this is important.
But from a high pressure area, right?
Yeah, from wherever they are, yes. When there's a pressure differential. Now this is the lowest pressure you can go, 0 atmosphere matlab. So that is what causes these particles to actually like break apart and increase the space between them. So depending on how much space is available, either they'll turn from solid to liquid, but if there's like enough space, if there's enough of a pressure differential, then it'll turn from liquid to gas again. Okay, so always, if there is like vacuum or a low pressure area, matter wants to occupy it, which is why you have other phenomenon like diffusion and everything, like which is why evaporation takes place at certain conditions of pressure and temperature. Okay, so that is the reason when pressure decreases, solid turns to liquid, liquid turns to gas. But when you're increasing the pressure, you're pressing against those molecules. So agar gas hai, you're increasing the pressure, you're closing the distance between them. So gas turns into liquid, liquid turns into solid. Okay. Guys,
Ma'am, I had a question.
yeah.
What if we increase the pressure on a solid?
So that turns into liquid.
It'll break, right?
Huh?
It'll
Wait,
break.
you said increase the pressure on a solid. Oh, you increase the pressure on a solid, they will move closer, closer, closer. Eventually, it's gonna break apart. But after a point,
Can you give an example?
like it is physically impossible.
Okay, ma'am.
Yeah.
So
Doesn't that happen
into the
naturally as well?
In what context, Sahil? What do you mean naturally?
No, I'm asking, does it happen naturally?
No.
The breaking of that, like, I suddenly need to be super strong to break it. Can that happen?
It doesn't. Like you need to engineer the circumstances like that. Like pressure needs to be applied, right? Like automatically pressure apply nahi hoga. Either humans in their experiments you need to apply it, या फिर force of gravity की वजह से you're like increasing the pressure on an object. Something or other should trigger it basically. Yeah. Somebody else was also talking, asking something.
yes, ma'am.
Yeah.
Ma'am, so if the ice is in a vacuum chamber with no space, so what would happen?
Nothing will happen. See,
Yeah.
this change will happen only if you're changing the temperature or changing the pressure. If you keep it constant, कुछ change नहीं कर रहे हो तो matter में भी कोई change नहीं होगा. So if you change any condition, then the condition of this also will change.
So if you don't change anything, it will not melt at all.
No, if you maintain it at a certain
That's cool.
temperature, certain pressure, वो वैसे ही रहेगा. Like वही हो रहा है ना. अभी room temperature 27 degrees Celsius पे if you have a bottle of water, if you're not putting it on the stove, if you're not putting it in the fridge, if you're not like doing anything to it, उसका temperature उतना ही रहेगा. So all these changes happen only if you change.
The temperature slowly starts to reduce, no?
Sahil, one moment, let me complete, no? So all these changes will happen only if you change either the temperature or the pressure or both. Okay? If there is change in temperature or pressure, then matter ka structure may be change rahega. Okay? Yeah, Sahil, you were saying? Hello? Oh, you're under mute, Sahil, in case you're saying. Okay. All right. So you guys clear about this so far? Like change in pressure, क्या करेगा, क्यों करेगा, कैसे हो रहा है? You have an idea? क्या हो रहा है?
Yes.
Yeah. Everyone, Rashmit, Aliza, Jaydeep, Neve, Kushagra,
Yes, ma'am. Yes, ma'am.
Anvesha. Yeah. Okay. Cool. So let's see what else is there here. Effect of change of pressure. This is what I just discussed. Increase in pressure, like when you're compressing something, brings the particles closer. If they're closer, increases the force of attraction. So इसलिए the physical state also changes. See, इसलिए particles coming closer. When you're increasing the pressure, temperature का opposite हो रहा है. Like gas becomes liquid, liquid becomes solid. So if you're decreasing the pressure, like if you're doing the ulta thing, then the change is also ulta, reversed. So this is how gases are liquefied. So you lower the temperature to a certain extent, लेकिन उनको पूरा liquid बनाना है. Like if you want to produce liquid oxygen के tanks. So hospitals में you need oxygen cylinders, right, for survival. And even rocket fuel के लिए you use a mixture of hydrogen and oxygen. So how they store and transport all of this is they liquefy these gases and they do it. So liquefying के लिए lowering temperature works to a certain extent, but applying pressure also makes it easier, makes it quicker. You need to spend a lot less energy in terms of electricity or mechanical energy, जो भी है. Less effort to liquefy it. So make use of pressure. When a high pressure is applied to a gas, it gets compressed to a small volume. So when we also lower its temperature, again, the motion decreases. So both of them get add up and then they finally turns into a liquid. So gases can be liquefied by compression is basically increasing the pressure on it, and cooling is lowering the temperature on it. Ammonia is ammonia as a gas. Do you guys know what is the formula for ammonia? What is ammonia? Have you come across ammonia before?
Fertilizers.
Fertilizers, yeah, good point. Good. So ammonia is used in making fertilizer because it has nitrogen. So chemically, ammonia ka formula is NH3. Matlab, it is made of nitrogen and hydrogen. So ammonia is also another thing. So room temperature pe ammonia is a gas. But the way, like it's used in fertilizer factories and all, so ammonia is required for the manufacture of fertilizers. So how do they store and transport ammonia? Is they liquefy it by applying high pressure, lower temperature, and then they the liquid ko you can use pipes to basically transport it. Decreasing the pressure, raising the temperature can change the state of matter. So इसका opposite है. Compression changes gases to liquid. decreasing the pressure, like expansion, turns liquid to gas. The solid carbon dioxide, dry ice, is stored under high pressure. So it's not, so Sahil, you were talking about vacuum sealing, right? So it's not 100%.
No, I didn't see it.
नहीं अभी नहीं पहले when we were discussing. So dry ice also, it's stored under high pressure to keep it solid. So when you change the pressure, its state also will be changed. A slab of solid carbon dioxide is kept exposed to air, then pressure is reduced to normal atmospheric pressure.
Oh, okay.
Yeah. Temperature also rises, and then it starts changing into carbon dioxide gas. So as long as you keep it stored, nothing will change. But once you change its conditions, pressure conditions ho ya temperature conditions ho, then its state also will change. Okay. So this is a visual that I was trying to see. As pehle gas tha, as you keep compressing it, comes closer, and depending on how close it is, gas turns into liquid, liquid turns into solid. Okay, so application of this, like, because we see that pressure also affects the state of matter, real life mein this has real consequences. Okay, so in hill stations, like when you go up to hilly areas, higher altitude places, hill stations, or higher
The oxygen in the air runs out.
oxygen
Starts to get
out, yes. It doesn't run out, it reduces, yes. But also, will it be easier or more difficult to boil water? Boil water, cooking food, jaldi ho jayega ki time, like, or will it take time?
It'll be faster
That's gonna happen faster, but why?
because of the lack of pressure.
Yes. So boiling water is faster, or other words, easier. So another word is it happens at a lower temperature. Matlab 100 se kam, less than 100 degrees Celsius. So why is this? Again, boiling is converting liquid to gas, right? So already pressure is reduced, which means it's easier to convert from liquid to gas. So the amount of temperature you need to increase it by also reduces. So basically kya hota hai? So in still, like whenever it's a high altitude area, due to lower pressure, so if pressure is low, so like we saw here that decreasing the pressure turns liquid into gas. So because at higher altitudes, the pressure is low, so it's easier to convert liquid water into gaseous water. So boiling also happens at a lower temperature.
okay. So then at what temperature is boiling happening?
It
In the
depends on how much, yeah, it's not a set temperature because it depends on, like, we know it's a lower pressure, but by how much is it lower than 1 atmosphere, that will decide the temperature. Kafi low hai, if we go extremely high, it may boil at like 95, 96. But if it's like not very lower than surface level, then it may boil at like 98. So that depends on how much lower the pressure
So
is.
it cannot go to like 50 degrees boiling, right?
In the real life, no. But if you lower the pressure to such an extent, you can boil water at 50 degrees
Okay.
Celsius. Laboratory may all that. Okay. So this is like an application of it. Another thing. Okay, so like within gases itself, there's another process So one characteristic of state of like matter ke particles is that they are continuously moving. Particles of matter are continuously moving. And because of this continuous motion of particles, so if we have a gas, those gas particles are always moving. So whatever space is available to them, if you put in a small box or a bigger box, they're going to occupy that entire space. So that phenomenon is called diffusion. The process in which particles of a substance occupy the vacant spaces present in the particles of another substance is called diffusion. So agar koi, if there's other particles and other substances there, it will go inside them. If other substances are not there, they will just move around and occupy whatever space is available to them. Okay. So you can think of it this way. So suppose like if there's a big box here, and then you take a tiny box, make a tiny hole in it. Like this box is filled with like liquid oxygen or something. If you make a tiny hole in it, the gaseous substance present here, these molecules are continuously moving. They'll get out of this hole and they will eventually occupy the whole empty box. So this process of, the substance moving to occupy the extra space available, so that process is called diffusion. Here. So
Didn't we do diffusion earlier?
if we did, good, like ek aur revision ho jayega. So then I'll ask you guys questions based on this. So question number 1. If we open a perfume bottle, keep it in one corner of the room, you're able to smell it in the other corner of the room. What is the reason for that?
The fragrance is traveling with the air and it is moving from one point to another. And since it's spreading throughout the room, you're able to smell it.
Yes, but I'm looking for a technical, like a keyword that you have to use. What is that process called?
It occupies the space.
What is it called? I'm looking for one word. All of you?
Diffusion.
Diffusion. So use the keywords to answer questions, okay? So that sort of a question, say the particles of the perfume diffuses into the air, or due to the process of diffusion, the particles occupy the entire room, so we are able to smell it in the other corner. Use the word diffusion when you're answering such questions, okay? Okay, another question based on diffusion. Okay, let's say we have 2 plates of food. One is cold, abhi fridge se nikala, and the other is hot. Microwave mein dal diya 30-40 seconds ke liye. So which plate will you be able to smell from another corner of the room?
Amish, can you repeat? Your audio is breaking.
And the plate which is heated.
I'll just repeat the question, okay? So we have 2 plates. Let's call them A and B. Both have the same food. Okay. Now plate A is cold. We just took it out of the refrigerator. Plate B is hot. Like we just put plate B in the microwave for some time. So which plate will you be able to smell from a different
Plate B.
A.
Plate.
A.
Okay.
I'm not sure which one, but whichever the one you said you heated it up. No, that.
Yeah, the microwave one.
हाँ तो like वही लिखा है मैंने. A is cold, B is hot. So give me A or B.
Oh, then B.
B.
Sahil and Jayat saying B. Roshmit saying B.
B.
Aliza also saying B. Kushagra Anvesha. Okay, somebody sent on chat.
B.
Is saying B. Okay. Neil is also saying B.
And B.
B. Okay.
I think it's B as well.
Everybody is saying B. Awesome. Good, good. Pehle thoda I was like doubtful, but yes, B is absolutely right. But what is the reason? Why do you think it's B?
And because of the higher kinetic energy due to greater heat, there is more diffusion. We learned it in class today, ma'am.
Yes. Yeah. So temperature का effect क्या है? Like what did we learn temperature does to particles? What does it do, Jyoti?
Certain temperatures can change the state of an object.
State of an object, yes, but why does that happen? Like primarily क्या हो रहा है to make
It is weakening the intermolecular forces between the objects.
how is it doing that? Because pressure also is doing that.
Pressure?
No, we are talking about temperature. So it's doing that by increasing the motion of the particles. Okay, so movement increase हो जाएगा. Like if you increase the temperature, they get more kinetic energy, their motion increases. So plate B के particles motion is greater than plate A. So motion greater है मतलब they can move across the room more easily. So that's why you're able to smell the hotter one, but not really for the cold one. You need to put your nose inside to be able to smell it. Yeah. Yeah. So at this point, I think concepts, so you guys have it, but being able to answer questions, like that's where we need to spend some time. So that's what we'll do, like practice karenge a few. Have all of you downloaded and set up Flipper?
Yes.
Yes,
ma'am.
ma'am.
Yes, ma'am.
Awesome. I think
But it doesn't work for me.
how does, oh yeah, the Shani ma'am was saying that, so like some
Yes, ma'am.
keep repeating his na?
It
Was
is
that
there for every subject.
every subject? Acha.
Yes, ma'am. Everything which I've opened.
So yesterday only we came to know, like I forwarded it to the tech team. Have you sent in your registered email ID and like the account that you're using, mobile number or email ID or something?
They didn't tell me to send anything.
Okay.
And plus, Rohit sir, I think, has all of that.
Okay. Okay. So we'll check it. No, yeah. So sir had asked for your name. Okay. So they're checking it on the back end. Like once it gets updated, we'll let you know. Check it out. Okay. Effect of change of pressure ho gaya. Now coming to evaporation. Evaporation is pretty simple. I think you guys know like most of the concepts related to evaporation. So you guys tell me what you know about evaporation and then I'll fill in the blanks. So what is evaporation? Someone start.
Evaporation is the change of something from its liquid state into its gaseous state by the increase in temperature. For example, water into steam.
How is it different from boiling then? Boiling, maybe you're doing the same thing, right? Liquid say.
Boiling, I think, takes a lot longer and it is done on a smaller quantity. Evaporation can be done on a larger scale. Like, for example, oceans, I guess. Oceans also, na?
So are you saying like boiling takes longer or evaporation takes longer?
Boiling takes longer and boiling is done on a smaller scale. Evaporation is faster and larger scale.
Ma'am, is evaporation when water changes into gas, but before its boiling point?
Yeah, that is the key point. So evaporation. So Sahil, you were 90%, 50% correct. That change in liquid to gas, but it is not by increasing the temperature. So this is at any temperature below the boiling point. So room temperature pe bhi evaporation will happen. So think of your clothes drying. Uske liye you're not heating up your clothes, no? You're just like putting it outside and then the water evaporates on its own. So even at room temperature, this happens. So boiling may you are forcing the liquid to turn into gas. So liquid to gas matlab you're basically forcing the liquid to get at its vapor pressure. But in evaporation, you're not doing anything like that. It's a natural phenomenon. It happens on its own. Another thing, Sahil, you were talking about small scale, larger scale thing, right? That was a little
Yeah.
unclear. Better words to use is in the case of boiling. So we call boiling a bulk phenomenon.
I thought evaporation was the bulk phenomenon.
No. So boiling bulk phenomenon, because when you're boiling a pot of water, beaker of water, whatever it may be, so all of the water is boiling. Like niche se you see the bubbles rising. But in the case of evaporation, this is a surface phenomenon.
Oh yeah, only the surface is evaporating, but there's a larger surface area. So it doesn't result in larger evaporation, I guess. Is it right?
Yes. So so evaporation, if you have a larger surface area, greater evaporation will take place. That's more of a condition, like smaller surface area maybe evaporation will take place. Just that because it's a surface phenomenon, ऊपर जितना surface available है, उतना evaporation will take place. Okay. So these are broadly differences between boiling evaporation. Now, why is the liquid turning into gas taking place even at room temperature, even when we don't increase the temperature, increase the pressure, कुछ कर नहीं रहे फिर भी क्यों हो रहा है? Okay, so for that, let's zoom in again. This is, let's say, like your water. अभी water में it's made up of water molecules, सारे particles हैं. Evaporation बस surface पे ही क्यों होगा and क्या हो रहा है surface पे which is not happening नीचे. So let's focus on two layers of these water molecules, water particles. एक है surface पे and let's consider any other particle that's नीचे. Okay. So a particle that is somewhere inside, यहाँ हो सकता है, यहाँ हो सकता है, जो भी है, which is not on the surface. This is surrounded by water molecules on all sides. Abhi, you guys learned that particles ke beech mein you have intermolecular forces of attraction. So there is force of attraction on this side, yahan pe, then here, 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 here. So if I have a particle which is experiencing force equally in all directions, तो इसके ऊपर net force कितना होगा?
Zero.
Your voice was a bit muffled.
Oh, so I was saying the particle that's on inside,
Zero, ma'am. Zero.
zero. Right? It's all balanced on both sides. So this side say the particle that's pulling is balancing out the force on this side. So both of them cancel out and net force will be zero. Like it'll just stay in its place. Nothing is happening to it. Okay, get it? Now, take a particle somewhere on the surface. Now this particle is experiencing forces only on one side. The surface particle, there is force here, 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 and here. So upar se there is nothing else on top of this, so no other forces. Let's say side by side ye to cancel ho gaya, but we still have forces on this and this side and this side, no, the particles that are niche, which means the net force on particles on the surface is not equal to zero. So if it's not equal to 0, they can be pulled on either sides. They're going to flow this side and that side. By chance, as they are moving and colliding against each other, one random particle will get enough kinetic energy to be able to escape out in the atmosphere. Okay, so that's what we see as evaporation. And that is the reason evaporation takes place extremely slowly. Boiling, yeah, if you take a pot of water, put it on the stove, 10-15 minutes you'll have to wait and it'll all boil off. But evaporation, like when you're drying clothes, how long does it take to dry clothes?
So basically, evaporation takes longer than.
Yes, evaporation takes longer than boiling because you're not actively providing heat. One random molecule, like the conditions have to be just right. It needs to collide enough, it needs to gain enough energy to be able to escape the attractive forces of the particles around it and go into the atmosphere. So it's not a bulk phenomenon, only the surface molecules have that. So it takes longer. Practically also, you can see if you've like spilled water on the floor or on the table, it's not gonna like dry off in like 10-15 minutes, right? Naturally, agar usko evaporate hona hai, it's gonna take a couple of hours at least, right? For every single drop of water to go off. Okay. So that's essentially the reason for evaporation. Okay. Clear? Yes, Sahil. Oh, thanks for the applause. Unless that's not
Ma'am, doesn't the evaporation speed depend on where you are as well?
absolutely. So evaporation again because of whatever we studied. So one is only molecules on the surface are able to evaporate ना. तो अगर surface area ज़्यादा है, मतलब number of molecules you have on the surface is more. So greater surface area means more evaporation. And the second thing is temperature. So if you're in a zone of higher temperature, the molecules naturally have greater energy. So they have to like get lesser amount of energy in order
To escape.
out. Yeah. So greater temperature means rate of evaporation also will be greater. Similarly, wind speed. So ऊपर, if the wind speed is more, मतलब हवा है, so particles in the air are going to, like as they collide with these things, they are able to impart greater velocity, greater
Force.
energy on this. So greater wind speed matlab better rate of evaporation also will be greater. Okay. And humidity. Okay, so humidity is a new one. Do you guys know what do you mean by humidity? Everyday life may you must have used it, heard of it. Yeah, and
The amount of water. Can I try?
yeah, absolutely.
I think it's the amount of water molecules suspended in air.
Yes, it is how much water you have in air in the atmosphere. That is basically humidity. So agar humidity zyada hai, if you already have a lot of molecules of water in the air, what do you think will happen to evaporation? Will you have greater evaporation or lesser evaporation? Yeah, Anvesha?
Could you repeat your question?
If the humidity is high, extra humidity hai agar, so evaporation, rate of evaporation will be greater or lesser?
Lesser, right? Because
It'll
humidity
be
is the
lesser.
amount of moisture in the air.
Yes, already there's a lot of water molecules. So even if one gets out, there's a possibility that from the air one will get in. So yeah, rate of evaporation will be low. Drier climates may evaporation is better. Okay.
But if it is said that won't it like never happen? Like if a few molecules get out, immediately new ones replace them, and then it will take more time to displace those. Let them get loose. By the time new molecules will set in.
Both are happening simultaneously. That's why we said that it's not like evaporation will not happen. It's just much slower. It will happen eventually, but it's slower than it would be in drier climates. Okay. So these are the 4 factors. Evaporation, note this down because again, a lot of question. So it's a continuous ongoing process. Particles from the surface, they gain enough energy to overcome the forces of attraction present in the liquid, change into vapor state. So rate of evaporation is affected by temperature, surface area, humidity, and wind speed. So once you guys note these down, note it down in shortcut, note down factors of evaporation, note down these 4 words, and then just write, okay, temperature hai. So if temperature increases, put an upward arrow, evaporation decreases. Okay, you can note it down like this. Or instead of arrow, you can just write the words, temperature increases, evaporation decreases. Sorry, it's the other way around. The other temperature pe this also increases, no? Yeah. So you don't need to write the whole sentence. Write it in short form. You just need to remember कि दोनों में relation क्या है. Okay. Similarly, surface area increases, then evaporation also increases. Humidity increases, then evaporation decreases. Wind speed increases, evaporation increases. Let me know when you guys have finished writing. Then I'll discuss the application for each one. The real life examples. Once you guys are done with this, oh, it's already 4 o'clock. We'll do a few flipper K questions also.
Yes, what do I do? But paper doesn't work.
Just try it again, no, in case, or let me.
If it is live, I think then it might be a different thing because I only
Yeah,
tried
yeah.
to set the zone.
Okay. Like abhi we doing live. I'll check with the developers team kya ho raha hai, kya hua ki nahi. Yeah. Sahil, I wanted to ask you one more thing. The issue you were facing, were you doing boost or was it in learn that you were facing the issue?
No, it's like when you open the app, it says, no, urgent homework.
Okay. Okay.
So I just pick which is the easiest one, which I remember a lot, and I start with that. And it says like 5-6 minutes left. So I do that first. So
So
I just
can
do like
you,
that.
okay, after class today, can you just try it and can you send a screen recording? We'll be able to,
I don't know how to record a screen on a screen.
okay. So usually phone में होता है. Do you use iOS or Android, Sahil?
And 1 second, let me just check. I'll just bring the devices.
Yeah. Once you finish
I'm
noting,
the
don't stop this in the middle. Okay, Rashmit, Jaydeep, done. Okay. Neve, Neil,
yes.
Jayat, Kushagra, Anvesha. Let me know if you guys finish noting.
Done, ma'am.
Okay. Neve is done. Kushagra, Anvesha, what about you guys?
I'm done as well.
Done. So batao na, otherwise we're just like sitting looking at each other's faces.
I'm done.
Yeah. कितना टाइम हो गया फिनिश करके?
I'm just now.
Yes, okay. All right. So all of you, like if you have your devices, we'll do a live abhi. We'll start with the questions. Go live. Okay, this is the code. 782163. Okay, join the live session.
Miss, I brought the device.
Okay,
I opened Flipper also.
so abhi we'll start with the live session. Once we're done with the class, like maybe in another 10 minutes or something, I'll show you what has to be done.
Okay.
Okay. All right. Jayad, Neve, Rashmit, Jaydeep, Neil joined in.
Just now.
Yeah.
I forgot where to enter the code.
It's on your profile where your photo is ready. You click that, you get join live.
Okay, thank you.
Anvesha.
Just the number you have written on the screen is the code.
Yeah. Who's left? Kushagra, Sahil and Aliza have joined in. So Kushagra is the only one left. 1, 2, 3, 4, 5, 6, 7, 8. कितने लोग हैं इधर? 9. So Kushagra, yeah.
She joined.
Joined. आ गया. ठीक है. Start. So पहला question है arrange का question. Okay, so you need to like drag and drop. I guess
I solved the first question, but then I arranged it as air, exhaust and chimneys, water and honey, and it's showing the water and honey placements are wrong.
Yes, ma'am. The order is supposed to be air, exhaust, honey, and then water.
okay.
Wait, so my answer isn't wrong, right?
It's not getting loaded for me.
Can you show your screen? Like, can you turn on your video and show what's up on your screen, Neil?
Yes, ma'am. Just a moment.
I can see 7 people have answered.
Yes, ma'am. see my screen.
Oh, are you on Wi-Fi or mobile data, Neil?
Ma'am, mobile data.
Oh, can you switch to Wi-Fi and see?
Okay, ma'am.
It could be a network issue. Yeah. So two people who have not answered. Neil is one. Who else is yet to answer? Yeah. Okay. Double confidence. Okay.
Ma'am,
Never mind. Okay. Next question. Still not coming up. Okay, I'm going to the next question. Should come in now. Again, okay, arrange increasing order of density. Cotton, chalk, iron. Hey, first somebody answered गलत क्यों हो रहा है?
Now I'm putting in sequence and then submitting it, so it's not showing whether it's correct or not. It's just showing the solution
Oh, can you just take a screenshot and send it, Aliza?
on the group.
Yeah.
Ma'am, I'm unable to submit the answer. It's just showing such solution. There's no submit button.
Okay. That issue, okay, is still not sorted. Okay.
Ma'am,
Ma'am, it's
answer
still
will-
showing the answers are wrong because I put the order as cotton, chalk, and iron. It's still
Yes,
showing it as wrong. It's only showing the
Include-
option iron is correct.
नहीं, गलत होना चाहिए. ठीक है. I'll talk.
Miss, the order should be chalk, cotton, and then iron. I've been putting that and I got that right.
But clearly, like, cotton is less dense than chalk. होना नहीं चाहिए.
Yes, ma'am, I know.
ma'am, the
But
solution
this is
is
showing
wrong.
correct, sir. But
तो अगर question like content answer गलत है, मतलब just flag that question that needs to be corrected on the back end.